Okay, so this is like an emergency video because we're running out of time, and I've just been having problems uploading the video that I wanted to upload. So I'm just going to go through the cognition stuff and just do a really quick repeat of what we talked about in class, so that everybody has the notes that they need to take the quiz and do reasonably well on it. So, basic definition of cognition would be the use and retention of information. So we've already talked about retention because we talked about memory. So now we're really talking about the use of information. Specifically, there are like three categories of information use that we're going to look at um, other than retention. So number one would be organization of information, and number two would be decision making or problem solving, I should say. Number three would be decision making. Um, just basically in the field of cognitive psychology and in um, the information processing model and in subfields like sociocognitive psychology, for example, the concern really is not so much what the information is that we're dealing with, but how we process that information and how the way that we process that information contributes to our experience and our perceptions of the world and the way that we interact with the world. So we're talking about how we process information. Uh, a Another definition, and I think this is the one that's in your book, defines cognition as the manipulation of mental images or symbols. Um, so manipulation means that we have, um, well, it's the content of thoughts. So you have mental images, which are sensory representations of the object. So the way the things look, because we're using the word images, I guess it's easy to think about visual images as being what we're dealing with. But actually, a mental image can be comprised of any kind of sensory experience. So it can be auditory, or it can be visual, or it can be tactile, or um, basically any piece of information that comes in um, as part of our sensory awareness, um, we can think of as being a mental image. And then the second half of cognition, or the second half of thinking, is going to be the manipulation of symbols or thinking in symbols. So if mental images are sensory, symbols are verbal. So what they are is some sort of sign or some sort of um, well, a sign, a symbol, a thing that stands in for a concept or an object. And the reason that we think about this as being verbal is because it is really a verbal ability to represent an idea or a concept by a symbol rather than an image of the object itself. So, I can have a mental image of what a ball looks like, or I can have the symbol, which is the word ball, which stands in for the concept, um, and then allows me to articulate ideas about the object. Um, so we've got symbolic thinking, use of symbols. Um, so I just want to make sure that that's clear, that we have two components. We have mental images, and then we have symbolic thinking. So we've got a verbal and a sensory component to cognition. Um, so there you go. The next thing that I want to talk about is I want to bring you back to chapter 6 for a second here and just make a link between short-term memory and cognition. When we think about what cognition is, that it is conscious and it's directed and it's intentional and it's attentional, or we're focusing our mental energy on processing some sort of problem that we're working with now consciously. Um, it really makes sense to think about short-term memory and working memory and cognition as being similar processes, if not exactly the same thing. Um, for example, when we look at people who are performing a short-term memory task, their prefrontal cortex lights up like a Christmas tree. And it's the same thing when we give people a problem to solve. It's the prefrontal cortex that becomes active, that seems to be involved in things like organizing cognitions or forming a plan or analyzing risk-benefit analysis or cost-benefit analysis, and regulating behaviors, making choices, making decisions. So all these things that we associate with cognition, um, we also associate with short-term memory. So cognition is attentional and it's intentional, which means that we think about something by directing our attention towards that object or that problem consciously, um, and willfully, um, just like short-term memory. And if we want to plot out a model for cognition, we can use Baddeley and Hitch's model of short-term memory to explain cognition as well. So we have the central executive, which would be biologically would be the prefrontal cortex, um, organizing information and making decisions about how the information is going to be processed or what information is going to be used. And then we have the visual spatial sketchpad, which we can sort of extend to be like a sensory sketchpad. So that would be the use of mental images. And then the phonological loop, which would be the verbal component, symbolic thinking, the subvocalization. So it all fits really nicely into Baddeley and Hitch's model in terms of explaining the content of cognition. Okay, so the next thing is going to be talking about layers of processing. And so the summary here is that we've got two layers of processing. One of them is data-oriented and the other is conceptually oriented. So I'm going to start with data-oriented first and just make sure that that information is there. So data-oriented processing means that we're looking at the parts of the experience or the parts of the problem. Basically, we're trying to figure out what the problem is or what the object is using an investigative approach, looking at the object closely, trying to see what kinds of features it has, what are the components of the object, what is it comprised of, and using this idea of component parts I've sort of given away where I'm going with this, which is that there's a relationship between a data-oriented approach and structuralism. So when Wundt and Titchener were looking at the component parts of our conscious experience, that's really what they were looking for. They were looking for the individual pieces that comprise the individual pieces that we use to build our experience of consciousness. And so that's a data-oriented approach. So it was used by Wundt and Titchener, and then later theorists like Piaget, for example, are going to look at cognitive structures, cognitive schemes, the basic building blocks of cognition. What are the parts that are involved here? And a word that I'm going to use as we move forward is I'm going to talk a lot about features, especially as they relate to concepts. So features is just another word for the part, the thing, the detail, or the data that is part of the problem or the object or the experience, whatever we're talking about here. Okay, so this data-oriented level of processing is what's called bottom-up processing, because we start at kind of like the lowest level of analysis, which is just looking at the object, having a sensory experience, trying to gain information about what the object is. And it's really analogous to this idea of inductive reasoning, where we really are looking for the individual clue, and we're not putting the information together yet. We're not really understanding how the things work. We're just trying to figure out what is happening or what the object is. So as we kind of move forward and we get more familiar with the problem or more familiar with the object, what happens is there's a shift in the way that we process information, and we go from we move from doing a data-oriented approach to an approach that is more conceptually oriented. So the concept or the whole is kind of like the idea or the object as a whole or the situation as a whole. It's based on this idea of the Gestalt. So in Gestalt psychology, the idea is that the whole is greater than the sum of the parts. So we can look at the parts and we can analyze the parts individually, but once we've identified the parts, the way that we understand the object or the situation is actually not so much about what the parts are, but it's about how they function together or how they work together. Um, so that would be people like Max Wertheimer and Albert Bandura and Kurt Lewin, Julian Roeder, people who were involved in either Gestalt psychology or sociocognitive approaches, or cognitive approaches like just cognitive therapy or rational emotive therapy. Where the idea is not so much that it's the details or the actual facts of the situation that are important, but it's how we process that information in developing an understanding of uh, the stuff that we see. So this level of processing, we could refer to it as being top down because it starts with a general idea or an assumption or a heuristic that we apply probably based on some sort of prior knowledge or some assumption that we have about the problem, rather than starting with the investigative data gathering kind of approach. So we make some assumptions. We rely on intuition um, or prior experience in order to speed up the process of dealing with the problem and to do it more efficiently. So a data gathering approach, a bottom-up approach, is much more time consuming, and a top-down approach is more efficient and it's faster. And it's prone to error for a variety of reasons that we'll get into, but it is more efficient. And efficiency, I'm going to talk about it in a second, but efficiency turns out to be really important when it comes to this stuff. So the conceptual approach is similar to deductive reasoning. So this idea that we're not focused so much on the individual data or the individual parts, but we are interested in how they work together and drawing conclusions based on, I don't want to use the word assumptions like it doesn't mean anything, because they're intelligent assumptions based on familiarity. So one way to think about data versus concepts, or a data approach versus a concept approach, is to think about it in terms of what your experience is. So, for example, this is just a general psychology class. It's Intro to Psych. And in this class, you might be concerned with things like, what is the definition? What are the parts of each theory? What are the schools? What are some of the names that I'm going to need to know for the quiz? So the questions that you're asking are really more like what questions, like what's the data, what's the actual basic information that's required to answer a multiple choice quiz, for example. As you become more familiar with the subject matter, what happens is you move to asking questions that are more like how questions. So like, how do these schools relate to each other, or how did these theories impact the development of psychology over the course of the next 20 years, or whatever the case might be. So you end up in a slightly more flexible place where you're able to answer questions that are a little bit more in depth and a little more conceptual, a little bit more abstract and theoretical, because now we're moving away from a data-oriented approach and we've got this top-down approach that we're relying on at this point. So the familiarity would be the key feature there. Okay, so data-oriented approach, concept-oriented approach, bottom-up and top-down processing, inductive and deductive reasoning. Okay, so just moving forward to talk about concepts and features now. So the content of cognition, but we're also moving into the first one of these processes, which is how we organize information. So for the most part, we're talking about the concept, and what a concept is a group of objects that are grouped together based on some sort of shared feature. So we're looking at the details of the object and then putting it in a category with other objects that have similar details. Um, and the point here is that information that is organized efficiently can be recalled efficiently. So whether we're talking about it in biological terms, like we're talking about neural networks where different concepts are stored um, in areas of the brain with other related concepts, which makes it easier to find that information and identify that information, or if we're just talking about it semantically, like the semantic network model, for example, or a Wikipedia page. I mean, they're all examples of this idea that it is so much easier and so much more efficient to process information if it's well organized. And one way to organize the information is to group things together based on similar features. So it goes back to Gestalt psychology again, this idea of the law of simplicity or the law of pregnance, which, I mean, basically what it says, the essence of the law of simplicity is that there's a natural and innate drive, I guess, to categorize and organize information in a way that is as simple and as efficient as possible. And what it leads to is a kind of a, well, this would be the application of this data versus conceptual approach idea where we start off looking for the data because we want to know what the object is, but once we know what the object is, when we see other similar objects, we stop looking at all the data points and just start using efficient processes to try to identify whether the object belongs to that same category or not. So that's going to be the idea. We're trying to make cognition efficient. We're trying to make identification of objects efficient. So that it takes up less mental energy and we can do this stuff faster. Okay, so we have concepts as groups of objects with shared features, and then we have sort of like two subgroups of concepts, natural and formal concepts. So a formal concept is a concept that's based on some kind of rule where you learn the rule about what the concept is, and then the application of the rule is very black and white. So either a object is going to conform to the rule and be a member of this group, or it's not. Triangles by definition have three sides and three angles, and the angles add up to 180 degrees, and there's really no middle ground between a triangle and a square. Like, if it doesn't meet those conditions, then it's not a triangle. It would be some other kind of shape, whatever the rule is for that shape. But there is a definite rule that defines the limits of the concept or the limits of the category. So that would be an example of a formal concept. It's a rule-based concept. Most of the concepts that we're dealing with are not formal. They're natural concepts. And natural concepts are formed through experience, our experience of the object or our ideas about the object or information that we gather about the object, but not necessarily a specific rule. So what we see with natural concepts is that there's a lot of room for error because it's not, people have ideas about what belongs in a concept group, but they don't necessarily know the rule about it. An example would be like birds, like what goes in the category of birds. So we have a list of features that we think embodies the idea of birdness, that birds have wings and they build nests and they fly and they have beaks and they have talons and stuff like that, which most of us are going to get to. We're going to arrive at those conclusions through the experiences that we have of birds, just in daily life, rather than taking a class on ornithology and learning what the actual rule is about what defines a bird. Like, what defines a bird? How do you decide whether something belongs in that category officially? Like, what's the scientific understanding of what the limit of that category is, and most of us don't have that information. Like, I have an idea about what that might be, but I don't know it for sure, and so my judgments about what is and is not a bird, yeah, I'm not looking to the rule, I'm looking to prior experience, I'm looking to what I know about birds through the experiences that I've had. Um, so it's not rule based, and that doesn't mean it's more flexible. It just means that the rules that we have about what belongs in each category aren't necessarily based in the reality of what's there and what's not. Um, just to give you an example, every semester I ask this question, what defines birds? Somebody asks a question like, are penguins birds? Because penguins don't fit their naturally defined concept of birds because they don't fly and they don't appear to have feathers, even though they do. So somebody's confused about, like, well, are they birds? Like, do they belong in this category? And the answer is yes, they do. Objectively, they belong in that category. But if you don't have that information, then you could be prone to a misjudgment about um, what kind of animal they are. Okay, so we've got natural and formal concepts. Formal concepts are easy. Um, Natural concepts are a little bit more difficult. So we've got, basically four ways that we identify concepts when we're talking about natural concepts. Three of them are sensory, and one of them is more semantic, more verbal. So I'm going to start with the sensory ones first, and they're all based on the idea of comparison. So we start off with our ideas about what birds are, first of all, and um, the first approach would be to use a prototype. And what a prototype means is we have a general idea of the average or the best representative of the category of birds. It's not necessarily a real bird, it's just the image that comes to mind when you think about birds. So it's an image that contains the average, best representative set of features that defines that category. And like I said, it's not necessarily a real bird, it's just an object that appears to have the features that would be necessary to be a bird. So that would be a prototype approach. And then what you do is you see an unidentified animal and you compare it to this mental image of the prototype of what a bird is. And the closer it is to the prototype, the faster we make the identification that it belongs to that concept. So that's a prototype approach. The exemplar approach is similar because it's we're making a comparison, just like with the prototype approach, but the difference is that we're referring back to prior experience. So in this case, we are comparing it to real objects. We're saying, I wonder if that's a bird, and then thinking to ourselves about, like, oh, other times I've seen birds, what have they looked like? Like, what have their features been? How big are they? What kind of feathers do they have? That sort of thing. Referring to concrete experience rather than like this abstract idea of a prototype. And then we have family resemblance theory, which says that when we are looking at groups of objects, we look at the features, but we also give some leeway. So there can be differences, slight differences between one member of the group and another member of the group, and that's fine as long as they generally appear to be from the same category. So, with people, for example, with families, every member of the family looks different and they're identifiable as an individual person, but you still look at them and say, they share enough features with other members of the family that I can tell that they're related to each other. And we're going to do the same thing with family resemblance theory. Okay, so we got prototypes, exemplars, we've got family resemblance theory. And then we have sort of like the verbal artificial rules, necessary and sufficient conditions. So with necessary and sufficient conditions, what they are is they're conditions, they're rules about who is and who isn't a member of this particular group. So an example of a necessary condition would be something like all birds have to have wings. In order to be birds, they have to have wings. And so when you're identifying an object and you see this animal doesn't have wings, you can say to yourself, it's not a bird. It's a exclusion. that you make based on that information. Um, and with the sufficient condition, it's kind of the opposite. We look at the object, or we have a rule, a verbal rule says that birds are the only animals that have feathers, so if this animal has feathers, then it must be a bird, because what else could it possibly be? And that would be a sufficient condition. So we do the categorization based on the one feature or just a small collection of features and say, well, that's enough. Regardless of what else we see, it conforms to this rule, and so it's a member of the group. So there you have it. And in all of these cases, it's formed, they're based on experience, they're based on the knowledge that we gather ourselves, so we are prone to error. People make mistakes about this sort of thing all the time. And that's to be expected because, like I said, we're not all taking advanced graduate classes in birds and bird anatomy and taxonomy and stuff, so why would you know that? Why would you care? For the most part, we're just concerned with being able to efficiently organize and identify the concepts that we encounter on a regular basis where we need to make those kinds of determinations. So there you have it. Concepts and features. The second process that we're concerned about here is problem solving approaches. So hopefully this won't take too long. So I really have three. I have three problem-solving methods, and then I have a little bit of discussion about impediments to problem solving. So I'm just going to go through the list of problem-solving methods, starting with an algorithmic approach. So I just want to bring us back to data and concepts. Like I said, we've got this bottom-up reasoning, and then we've got top-down reasoning, where bottom-up is more data-oriented and top-down is more conceptually oriented. So when we're looking at algorithms and heuristics, we're really seeing problem-solving methods that are based on a data approach in the case of algorithms and a concept approach in the case of heuristics. So an algorithmic approach uses the data of the situation, and what you do is take a step-by-step approach, one step at a time, working through the problem until you find the solution. So an example of this would be something like if you don't know anything about computers and your laptop breaks and you are trying to fix the problem yourself, you open a troubleshooting manual and you start from page 1 and you just work your way through until you find the solution. So it's really an approach that's useful when you have no prior information about the problem. You don't know what the problem is, you don't know how to fix the problem, you can't even identify the problem, so you just open the manual and you start from page 1 and basically just look at it from a data standpoint. Like, this is page 1, this is what it says, if it doesn't work, I move on to page 2, and follow this systematic approach until you find the solution. So that would be an algorithmic approach. A heuristic approach is more conceptually based. And what you do with the heuristic approach is you develop rules of thumb. I mean, that's really the key term. A general rule that generally applies in situations like this. And where you get that information is from prior experiences or prior information that you have or some familiarity that you have with the problem. So if your laptop breaks and you know something about computers, you might be able to look at the situation and rule out certain potential solutions because you know that those solutions probably won't work, and so you start to narrow your choices based on prior experience or prior knowledge. And what you end up with there is a faster approach to problem solving, but also an approach that is prone to error because you could be misinformed. You could have the wrong information, and that could lead you to pursue a solution that's not actually going to help the situation. So the idea is the algorithmic approach is slower but will lead to a solution eventually, and the heuristic approach is faster and may not lead to a solution. So you have a bit of a trade-off between those two approaches. The third approach to problem solving I'm going to mention because it's really the only time in this chapter that we discuss anything that has to do with the unconscious, and that's insight and intuition. So the idea is that in the process of problem solving, in order to think about solutions to the problem, we have to focus on the problem, we have to concentrate on the problem, and we end up in a situation where in a way, like distracted by the problem. So you're trying to find a solution to the problem, and you're trying so hard to solve this issue that you're actually not really thinking in an ideal way about the solution to the problem. And what ends up happening usually is you just get stuck on something. You get fixated on some aspect of the problem, and we'll talk about that in a second. And what you need, in a way, is an opportunity to distract yourself from the problem so that you can start thinking clearly, or at least being receptive to the information. And the idea behind insight is that we're processing information about the problem. Whether we're aware of it or not, we're subconsciously or unconsciously seeking solutions, and we're just not hearing that voice if we're so distracted consciously by the problem that we're facing. And so we end up in this situation where we can't solve the problem while we're looking at the problem, but then if you step away from it and go like take a shower or something, while you're in the shower, you'll have that aha moment and you'll say, oh, okay, that's the answer that I was looking for. And that's why people say things like they have their best ideas when they're in the shower, or when they're cooking, or when they're doing something other than trying to solve the problem, because that distraction sort of frees up whatever the subconscious information was that was being held back. So we sometimes talk about insight as being a two-phase process, where the first phase is what's called the guiding phase. And in that phase, we have this subconscious or unconscious gathering of information about the problem. And then in the second phase, which is the integrative phase, we have conscious awareness of that information. And that's where we have the moment of clarity where the solution becomes obvious. And this stuff finally kind of punches into the conscious mind, and you develop your awareness that way. So there you go. Algorithms, heuristics, and insight. So now what I want to talk about is impediments to problem solving, and really we're just talking about fixation here. So fixation is getting hung up on some aspect of the problem or some aspect of the tools that you're using to solve the problem, to the extent that you can no longer think creatively about solutions when one solution hasn't worked. So fixation is really a product of something that's actually good and that's actually efficient, and that's the development of mental sets. And basically what we do is, as we solve problems, we develop kind of a library of tools that we've used successfully to solve that problem in the past. And then when we encounter a familiar problem, we use the heuristic approach, and we go to the toolbox and we say, oh, well, I've used this tool to solve this problem in the past, so I'm going to use this tool here because it's a similar kind of problem. And for the most part, that's going to work. There are just going to be situations where, because every problem is different, a problem that appears to be similar to one that used this particular tool actually uses a different one, or a different tool might be more efficient, or just in general a better solution to the problem. Or the tool that you would normally use is no longer available, metaphorically speaking or literally speaking, in which case the fixation is going to cause like a kind of cognitive paralysis. Like, I can't use the strategy that I would normally use to solve this problem, and so now I don't know what to do, or the strategy that I would normally use isn't working, so now what do I do here? So that would be the issue with fixation. A lot of times what fixation is a because we're using a heuristic approach and we're not really gathering data, we're looking at the problem and we're saying it looks familiar, so I'm not really paying attention to the specific rules or features of the problem. And what that leads us to do is kind of impose limitations that may not actually be there, by creating rules that don't exist and then getting hung up on those rules. And let me give you an example of that. So functional fixedness is an example of what I'm talking about here, where you have a rule based on your familiarity with the situation or the object, and you apply that rule, and it's not really appropriate to apply that rule because the reality is that the rule doesn't exist. And the idea of functional fixedness is stuff like, if I have a pair of scissors, scissors are used to cut objects. These are child safety scissors, so it's probably construction paper or something like that. Um, Functional fixedness says that I get so used to using this particular tool for this particular function that I begin to think really inflexibly about using this tool for other things. Um, and what that means is that there might be a problem that this tool solves or could solve, but I'm not necessarily going to access this tool because I think of it as being just for cutting construction paper and not for, um, I don't know, shaving or something. My wife likes to tell a story about an ex of hers who criticized her because she used scissors to cut chicken. And she was cooking chicken and she was like cutting it into strips, and she had just used a regular pair of scissors for that. And he apparently went nuts because that's not what you're supposed to use scissors for, and was just like on this diatribe about it. My wife she's more like me when it comes to that sort of thing, which is the tool that solves the problem is the correct tool for the problem. So it doesn't matter if it's kitchen scissors. It doesn't matter if it's like shears for cutting tree branches. Like if it accomplishes the goal, then that's the thing that's important. But if you're kind of like hung up on this like detail about like whether or not this is the way that you're supposed to solve the problem, then that's obviously it's going to create impediments to problem solving. So there's a relationship between fixation and functional fixedness in mental sets and this idea of creative thinking. When we try to identify what makes people creative, it's really the ability to see the tools in the toolbox, but to not get hung up on their familiar functions. To look at the thing as it actually is and say, this thing has more functions than what I've used it for before, and it may have applications that I haven't discovered yet. So it's worth it to kind of think about whether or not this could solve a problem that I haven't yet identified. Um, so, I mean, I'm not sure that this is going to show up on the quiz, but when we talk about creativity, we talk about the difference between convergent and divergent thinking. And again, we're really just using analogs for these data and concept-oriented approaches, where with convergent thinking, it's a data-oriented approach. So we look at the multiple points of data, and then those points converge on a solution to the problem or the solution to the problem. And with divergent thinking, we start off with the problem or with the tool, and then we branch out looking for more solutions or more ways that we can solve the problem. And obviously divergent thinking is the creative approach because you're not limiting yourself based on the expectation that one thing or one solution has to work. But anyway, that would be the stuff on creativity, really. It's about fixation. It's about getting past fixation and being able to access your mental energy and your cognitive energy without getting stuck on some of these details about the way that things are supposed to work. Okay, so the last thing I want to talk about here is decision-making processes. With decision-making, with problem-solving, with organization, the prefrontal cortex is supreme. So when we think about what the prefrontal cortex is responsible for, it's things like behavioral inhibition, emotional regulation, decision-making, risk assessment, understanding of cause and effect, in addition to things like concentration, problem solving, attention, memory, that sort of thing. So it's really, really critical in decision-making processes. So I just want you to be aware of that. The idea here is that we've got two ways to make decisions. So the first way, kind of like the idealized way, is what's called rational choice. And in rational choice theory, you're basically doing mental math. You're multiplying the value of, or I should say the cost of the choice by the probability of success, and then what you come up with is the value of the choice. Not the probability that you'll succeed, but what's the value of that particular selection. And under ideal circumstances, that would work. People would make intelligent, rational decisions based on a cost-benefit analysis, based on actually figuring out like what is the value of this choice versus this other choice, and then um, nobody thinks that way. Nobody does that math. Um, First of all, so very few of our decisions are made that way. Most of our decisions are made kind of emotionally, actually. But even when we try to be rational and we try to do the math, we run into this problem where we don't really understand. Either we don't have access to the probabilities or we don't understand what the probability means. So the probability of success, is a tricky concept because how do you understand that if you don't understand how probabilities work? Um, and the hypothesis is that we don't really understand how probabilities work. The idea is that what's called the frequency format hypothesis, that we're really good at thinking of things in terms of frequencies, which is how frequently something happened in the past, and we are significantly less adept at thinking about things in terms of future probabilities. So what we have a tendency to do instead is use the past as a measuring stick for the future. So we think about probability, just when I say this, it's going to be obvious why this is wrong. We think about future probability in terms of past occurrences. You know, we run into some significant problems as far as like evaluating risk is concerned. Let me just give you an example of this. I took a math class when I was in college, and we talked about statistics and we talked about probability. Um, and we talked about the odds involved in a coin flip. So if you flip a coin, the odds that it'll land on one side or the other, it's pretty clearly 50-50. So I had a student argue with me about that one time. So just assume that it's 50-50. So heads or tails, 50-50. If I flip the coin 9 times and it's heads 9 times in a row, what are the odds that it's going to be heads on the 10th flip? And it's really an important question because what it's asking you is, does the past occurrence in any way affect the future occurrence? And the correct answer is no, it doesn't. So every time you flip a coin, there's a 50% chance that it's going to land on one side or the other. And the fact that you have this streak of 9 consecutive heads doesn't mean that there's a lower probability of a 10th consecutive head just because of this past occurrence. But people kind of emotionally, like irrationally, look at that kind of situation and say that they'll say it makes sense that it would be tails, it would be more likely to be tails on the 10th flip because what are the chances of 10 straight flips of heads? There's got to be some variation there, but that's not actually a rational assumption. If we start off at the beginning and I say, what are the chances of me flipping this coin heads 10 times in a row? That's a different question from saying, what are the chances of this coin coming up heads after having done 9 flips in a row and getting heads 9 times in a row? Like they're totally different questions, but we're not really good at differentiating between those two ideas. So we end up in a situation where we fail to understand probability, and what that does is that affects our ability to think rationally about our choices and really evaluate whether or not we're making the correct decision. So we come up with some shortcuts to get around this limitation, and they're heuristic approaches because they're not based on data because we don't have the data or we don't understand the data. We don't understand probability, so we can't really do the rational choice formula. So instead what we do is we rely on heuristic approaches. We sort of default to a top-down approach in order to make decisions. And with representative heuristic, the idea is you're going to make a decision based on how similar the current situation is to the idea or the concept that you have of the negative or the positive outcome. And I know that sounds very abstract. So an idea about it would be you're walking home at night and you're going to make a decision about what street to walk down based on which street you feel like is the safer street, and you're going to make that determination not based on any statistics that you know about how frequently crimes occur in these particular neighborhoods, you're probably going to make that decision based on whether or not this particular street or neighborhood looks like the place where a mugging would take place. Um, it's not based on the details of the situation at all. It's just based on a sensory and emotional impression that you have, because you don't have access to that information in most cases. And if you do have access to that information, then you make the rational choice. And we're not, then we just sort of avoid this whole situation. So that's the representative heuristic. And the availability heuristic is a very emotional evaluation that we make based on how easy it is for us to conjure up mental images or memories of a particular outcome. So, for example, in the months following 9/11, when we think about holiday travel in that December and January of 2001 and 2002, after 9/11, a lot of people made decisions not to fly out to see family, and instead what they did is they drove to their destinations, because after seeing these really horrifying images of planes crashing into buildings and stuff like that, they made kind of an emotional decision about their relative safety and said, well, I'm not safe flying. And that determination was based not on any statistical knowledge and not on any, it wasn't based on facts or numbers. It was just based on an emotional evaluation and the availability of these images in their memories. Because when we look at the facts, airplane travel, even in that year with those fatalities, is still significantly safer than traveling by road, per mile traveled. And that reality was held up by the increase in traffic-related fatalities over that holiday season, because they increased traffic on the road because of people thinking they would be safer. And if that's not irony, then I don't know what is. You don't take a flight because you don't want to die, so you drive believing it'll be safer, and that's actually the thing that kills you. But that would be an example of the availability bias in action. So there's that. I want to talk, this is the last thing, I want to talk about prospect theory, because we're talking about emotional decision making, and prospect theory is a really good example of that. And basically what prospect theory suggests is that in a situation where you have to make a decision, we're going to make the safe decision to protect what's already ours, or what we perceive to be ours, rather than risking what we have in order to potentially gain something more in the future if it involves a loss or a possibility of loss of what we already have. The shorthand term for this would be risk aversion or loss aversion. And the way that it affects your decisions is that once you feel like you've made an investment, or once you feel like you have ownership over something, or once you feel like something belongs to you, you're going to act to protect that interest that you have, rather than being willing to explore other options which might actually have better outcomes, but which might involve you losing your prior investment, or the thing that you have ownership of. So this is a thing that retailers and advertisers, they exploit really well, because they'll try to advertise in a way that implies that you already have ownership of the thing they're trying to sell, because then that motivates you to protect that ownership by actually buying the object. Car dealers will run these advertisements where they say, stop by today and pick up your new car. And they're using the word your to establish this like subconscious emotional relationship between you and the thing they're trying to sell, where you do think of it as yours, and then you are kind of in a rush to go buy this thing so that nobody else takes your car. And they'll say things like that on the showroom floor. They'll be like, well, I got a lot of people who are interested in this car, so if you want it, you're going to have to act fast. And the idea is that imperative to buy the car is based on this idea that you, on an emotional level, believe that it's already yours, and you're trying to protect your resources by securing it. And the thing that these salesmen or salespeople don't want you to do is they don't want you to walk in there with an attitude like, hey, I could buy this car, I could get any other car, or I could not get a car, you know, like it's your job to sell to me. And in the end, what ends up happening for most people is they end up kind of selling to the salesperson, like trying to convince the salesperson, like, yeah, you should let me keep this car. Um, and it's kind of ridiculous, but it's a thing that definitely works. So we end up in this situation where people are protecting what they have and then making choices to preserve what they have rather than to maximize their gains. Um, so that would be prospect theory. And an application of this is what's called the sunk cost fallacy, which is a cognitive error that people make. When they're evaluating risk and they're trying to make decisions, the sunk cost fallacy basically says that the more we've invested in a decision, the more we consider that investment to be ours, and the more we try to protect the investment, even though it ends up costing us more in the long run. So we will continue to, we'll double down. We'll continue to sink money or time or effort or emotions into a situation that's not working because we don't want to lose what we've already invested by walking away from that situation. Um, and of course, the reality is that a losing proposition is a losing proposition. And if you're investing time, money, and energy into it, you're never going to get that back anyway. So you might as well just walk away from the problem. But what people do is they entrench and they double down and they increase their investment. And then the longer that goes on, the harder it becomes to break away from that because you're just increasing the time and you're increasing the amount that you've put into it. So there you have it. Hopefully this is enough. If you have any questions, obviously you can email me and we'll try to hash it out. And hopefully this will upload. So we'll see.